All right, ladies and gentlemen of Algebra 2, welcome to 2.3, talking about scatter plots. Scatter plots are actually pretty useful because all you're doing is you are graphing data and coming up with a line of best fit. So I can kind of talk a little bit about what that means in a second here. But basically what you're going after is constructing and analyzing a scatter plot and right in the line of best fits. When I start to take a look at here, scatter plots start to look at one of the bigger ideas of what is algebra. You look at patterns and relationships in data, generalize, and then use the data to make predictions. So you use prior knowledge of slope and linear equations, so you should remember what those pieces are, and let's get into it here. So we look, all states in the District of Columbia have enacted laws setting 21 as minimum drinking age. This table shows the estimated cumulative number of lives these laws have saved by reducing traffic fatalities. So here you go. So in 1999, it was 19.1. 2000, it was 20. So 2001 was 21. So 2002, 21.9. 2003 was 22.8. So you can kind of see it's a pretty flat line going along there. Okay, so when I kind of sketch this line, I want to look at kind of what I'm dealing with here. So when I go to graph it, kind of what does this line look like? Now, be very, very picky, and your point is you're trying to hit as many lines as you can going through here, and then try and graph from there. So if I take my line of linear regression, what I end up getting is this. So all I did was like count this 0, 1, 2, 3, 4, 5, 6, and so on. So when I do that, I end up, and I actually did it on a calculator, and I can show you guys how to do that, and it's really kind of slick. So you kind of end up going 0.93x, not quite 1, equal, not equals, plus 19.1. And I want you guys to do this on a calculator, so it's not really very difficult. I can show you pretty easily. So this ends up being kind of your linear equation. So what they want to know is what would the calculation be for 2015? Well, if 1999 is year 1, all right, then 2015, that's going to be year 16. So all I do is put 16 in here for x and figure out my answer. So I'm going to take 16 times 0.93 plus 19.1. So I get it to be approximately 33.98, which I'm hoping you'll kind of see there's a slight upward trend with the graph. So if I go all the way out here to 15, yeah, it should keep coming up, and that's where I'm going to end up. So scatter plots, positive correlation, quite easy. Negative correlation, negative slope, no correlation, you kind of got all over the place. All right, so my line of best fit is going to be y equals mx plus b, just like you guys have seen since about 8th grade. But what I'm doing is I'm trying to draw this line as accurately as I can, okay? And I want to be able to tell, is it a positive correlation, negative correlation, no correlation? And I can kind of show you how to do this on your calculator to help you out, just to kind of make your life easier. So please let me help you do that. Okay, so that is that's kind of the basics of scatter plot. So here, this I'm hoping is not too much of not too terrible for you. So if I start looking 5, 9, 3, 12, 1. So my x's, I'm going to count this as the hours. And I'm going to count this as the grade. So I go 1 to 12. So maybe I want to go 0, 2, 4, 6, 8, 10, 12. So every one's worth 2. Then going up, I think I want to go, let's see, I go from 70 to 98. So maybe I want to start at 70 and go every 5. So 90, 95, 100. So at 1 hour, I got 70. At 3 hours, I have 75. At 5 hours, I have 80. At 9 hours, I have got a 95. And at 12 hours, I've got a 98. So it's a very, very spread out one here. So I'm going to go kind of draw my line like so. And I would probably say that as I come down, I'm probably going to be at 0 hours. I'm probably going to be in the neighborhood of 65. So if I look, so if I go 5, 9, 3, 12, 1, then I go 80, 95, 75, 98, and 70. So if I run a linear regression, or I figure that out, I get it to be, my slope to be about 2.7, and my y-intercept to be 67.25. Okay, so if you're in the neighborhood of 67, if your slope was approximately 3, that's probably pretty good. So my equation of regression is going to be 2.7x plus 67.25. So if I figure out x, I'm going to go 2.7 times 10 plus 67.25. So that's going to be 94.25, which should kind of match up with what I have up here. So at 10 hours, I'm at about 94. Yeah, that's pretty close. All right, here's scatter plot for this. So if you can just kind of sketch a graph on here. So, you know, sketch one. Wait, I don't want to do that. Hold on, back up. I don't want this. I just want to sketch a scatter plot. And you can do it however you want. You can sketch one. I like the idea of just putting in the calculator and letting that do the work for me. So what I'm going to do is, I'll call 1985 like year 0, 5, 10, 15. So I'll go 0, 5, 10, 15. And then I'll go from there. I'll go 18.4, 25.2, 33.1, 37.6. So when I run this, my slope ends up being about 1.3, and my y-intercept is about 18.75. So if you had somewhere in the neighborhood of 19, slope of a little bit more than 1, you're fine. So my linear regression line is going to be 1.3x plus 18.75. So my attendance in 2010, so that's going to be 25 years after I start. So if I take 1.31 times 25, 1.3 times 25 plus 18.75, I get 51.25. So that's going to be my attendance in millions after that many years. All right, so taking a look, so if you have a game called El Diablo, and this is how they play, so I'll go 1, 3, 5, 7. My scores range from 52 to 83. So I'll call this 50, 60, 70, 80. I'll count each one as 5. So at 1, I'm at 52. At 3, I'm at 67, which would be right up here. And at 7, I'm at 83. So that's going to be right up here. So if I draw that line, and again, I'm using the calculator. If do your best. If you don't use a calculator, don't want to use a calculator, that's fine. Do your best kind of with what they're giving you. So if I calculate this, I get a slope of 5 and a y-intercept of 49. So it's going to be y equals 5x plus 49. So forget about the attendance for 2010. That's going to be what it's going to look like. So on, don't worry about this. Let's take a look at this quick. All right, so mean, median, means your average, median is your middle. This is stuff that hasn't changed. Q1, Q3, minimum, maximum. Minimum is your lowest, so if as I go through, your minimum is going to be your 19. Your highest, looking around, I think the 94s are going to be your highest, so that would be your maximum. So remember, these kind of pieces all work together. So what you're looking at is, as I go through and I line all these up, I start at 19. I think the next highest or the next lowest is a 34, then a 66, and it goes on and on and on all the way up to the 294s. Your median is right in the middle. Your Q1 is your middle of the lower half, your Q3 is the middle of the upper half, and your median is right in the middle. So as I kind of go through here, and I'll be completely honest, I let the calculator do a lot of the legwork for me, and I can show you how to do that. What I'm looking at is what's the middle of the lower half, middle of the upper half, median is in the middle. And so what I did was go, my Q1 would be 69, my median is going to be 76.5, and my mean is going to be 73.9. Mean is easy, average. Add them all up, divide by 20. All right, median means line them all up, all 20 of them. I think there's a 66 and all the way through 94 and 94. And start canceling them out from either end until you get to the middle, or take the average of the middle. So that's going to be kind of how I figure that out. And if you want me to, if you can line them all up and cancel them all out and add the middle, that's fine. Otherwise, I can show you how to let the calculator do a lot of the legwork. Same kind of idea. Let's skip here. Find a scatter plot for this. So again, I'm going to graph it and then figure out what it would be for 2016. So I'm letting this be the X, this be the Y, and I'll let you guys can sketch your graph or let your calculator do it for you. I want to let my calculator do it for me. So I'll let this be like year 0. So I make that 10, 15, 20, 25. I guess that would be 28, 30, and that would be 32. So as I graph this and I put those numbers in, I should be able to calculate it out. So when I start to crank this out, I end up getting a slope of about 1350 and a y-intercept of about 8470, approximately. So if you're somewhere in that neighborhood, there's going to be a little bit of wiggle room. So I get y equals 1350 x plus 8470. Again, that's approximate. If you put that on a quiz or a test, you wouldn't be wrong. So to 2015 from 1970, that would be 45 years. So that's like saying x is 45. So if I put that in, plus the 8470, oops, I get approximately $69,213.70. So that's going to be approximately. So that would be about as close as I was going to get. All right, so you guys can fill in this part and kind of figure out what I'm looking at. So figure out your mean, median, mode, put all that in and kind of let it do the work. So this is for Pacific states. This is for your Southwest Central states. All right, show that to me. I can show you how to do it on a calculator, and then come talk to me with questions.